Comes.
Hey, Richard Stallman, we are here.
Hi, can you hear us? Oh, wait.
Put on your
Yes, I can
headphones,
hear you.
Richard.
Can you hear us, Richard?
Yes, I hear you.
Okay,
We
I
have
hear you.
Richard Stallman on here. All right.
nice. Kid, do you like to stay in the channel?
Yeah, we'll just keep you on the channel, Kit, so you can hear this if you want.
Yeah, just listen.
All right, I'll go take a whiz, get a sandwich. I'll be here. I'll just be here.
Okay.
Okay, great.
I'll be
So,
back.
Richard, we are now connected to you as well as to Kit through Skype, but you won't see him, but you'll
Ugh.
see us.
Skype, proprietary software.
I
that
know.
spies on
Sorry,
people.
Kid.
Ooh, bad word.
Oh, we should have. I should wash my mouth with soap
Yeah.
for saying that
No,
word.
it's important to talk about these things. To avoid taking up time, look at stallman.org/skype.html for the reasons why you should refuse to use Skype. And those are why I refuse to use Skype.
Yeah, anyone should inform himself there. And yeah, we would like to begin in the very early years of you with Homebrew Computer Club. You have been a member there, right?
I'm not even sure what it was.
Okay.
I never built a computer myself. I had a giant computer to play with, the PDP-10 at the Artificial Intelligence Lab. It had basically a megabyte of memory, which in 1971 was a giant memory. We called it the Moby memory. And since I was one of the system hackers, I could add any useful feature to the operating system that I could write. So why bother making or using a tiny computer? It wouldn't be as much fun. So I never had anything to do with microcomputers, and I mostly avoided mini computers. They just weren't powerful enough to take me away from a PDP-10.
You have worked on the MIT AI lab, right?
I worked at it and for it.
Yeah. Can you tell us or talk about that time, please? What systems were you working on? And
The system we used was the Incompatible Time Sharing System, or ITS. The name, of course, was a joke, but the system was serious. That was the time sharing system that we ran on the PDP-10, and when we did computing, it was on the PDP-10 on ITS. Now, there are a couple of notable, interesting things about ITS. The only high-level language it had was Lisp.
yes.
Other than that, we programmed in assembler language or a few string processing languages that were rather curious, but were only rarely used, except for one, which was the Tico language, because Tico was not just a string language interpreter, it was also a text editor. So I wrote Emacs in Tico. Emacs was a higher level edition based on Tico, but it provided a completely different command set. The commands were implemented as Tico programs in the original Emacs.
Okay.
Now, aside from this, all the programs were in assembler language. And so one of the nice things was that the shell, and we didn't call it a shell, but we had one, it was also the assembler language debugger. So you could stop any program at any time and just look at the instructions it was executing. You could load in the debugging symbols if you wanted to figure out what was going on, and you could patch the program too. So if you found a bug, well, of course you could reassemble and restart the program, but you didn't have to. You could just insert a patch by depositing the instructions into memory one by one. And you could patch the running operating system kernel as well, because it was written in assembler language also. And you could direct the assembler language debugger to look at the running system with its actual memory, and you could change the instructions in memory, and you could also fix bugs that way rather than restarting the system.
What was the sample rate for the audio?
Well, it didn't have audio in the usual sense. The only audio it had was that it could change bits in one register. And actually, we didn't do this in the PDP-10, but in the PDP-6, which was basically similar and was used non-time sharing, there was a program you could run which would play music by turning bits on and off, and in one particular register, and that was connected to some sort of signal output. And so you could generate square waves of whatever frequency you liked. And there was a program that would take a series of notes and process it so you could play it this way. It could play up to 6-part music, and it was often used for Baroque organ music.
Just like Steve Wozniak's Blue Box, because his Blue Box would also generate square waves, which the telephone company did not like.
Well, I don't know. We didn't run this through a telephone ever. We just played it right there in the lab. There was no audio output device on the PDP-10. It was made to be used for time sharing by lots of people. It was as big as a pretty large room.
Wow. So this was all on a PDP-6 then, right?
No, the PDP-6 was the older machine that was used standalone, and the PDP-10, which was the same instructions but much faster, that was used for time sharing. Another fun thing about this system is that there was no security. There were no passwords. There was no file protection. You could log in as any name you liked and do absolutely anything. You could read or write any file in the system. And this was intentional. The hackers who wrote the system at first, they realized that if they implemented any kind of security, then the administrators would use it to control them and make their lives difficult and stop them from doing their work because they'd have to get permission. So they made sure this wouldn't happen by not implementing security.
But it was timeshare though, right?
Yes. And so I can prove that the AI lab that the ITS was the only system on which nobody ever broke security.
Because there was none. Sick.
Absolutely.
Totally
Much
sick.
more fun to avoid security than to struggle to break it when it stops you from doing your job.
Yeah, that's crazy. And
So the point is, hacking does not mean security breaking. We were hackers. Most of the hacking we did was things like developing the time-sharing system. I wrote Emacs. This was hacking. But we didn't ever break security because we made sure there was no need to.
And then you developed all the GNU family. Is it okay?
That's totally different. You see, the free software community, the AI lab and some other labs were part of a software sharing community. The software we used was free software, but that community died in the early 80s. And I had other experiences that taught me how a non-free program is an injustice. It oppresses the users. The developer or the proprietor, perhaps better said, has power over the users by controlling what the program does, and the users can't change it. Well, I concluded that that was an injustice, and because my community had died and the PDP-10 was obsolete, ITS was obsolete, I faced a future of being restricted by others and developing software to mistreat other people. So I would be mistreated and I'd be mistreating others. It was evil in all directions, and I said no.
Tell us a little bit about the early MIT days and the ARPANET, where the ARPANET was kind of like a gentleman's system. Because I can remember back in the days when I was computing in the, I think it was like the early 70s, maybe 72, 73, right after I got busted, I got access to the ARPANET. And it was the first time I did that. And they had a gentleman's system. You could log into a guest account, and you could do all kinds of really cool things.
Oh.
Tell us about that.
Well, until around 74 or 75, all machines basically had guest accounts. And then most of the machines took away their guest accounts. They said, the network is too big, it's impossible. And we continued to have guest accounts until 1992. Proving that they were wrong.
You're talking about MIT, right?
Well, the MIT AI lab. MIT
yeah,
had
okay.
other computer facilities too, with a totally different spirit and different rules and so on.
I can remember one time we were using the I think it was a Maxima chess program, the Greenblatt chess program, and we were duplicating the Stanford University's chess moves with the MIT chess moves, and we were using two computers where we were duplicating one computer to the other computer, and we were basically playing MIT against Stanford. By the way, MIT won.
Well, anyway, you were certainly using ITS if you were doing that in the 1970s.
Yeah, probably.
But the point is that it was there that I learned what it's like to live in a community where people cooperate with each other because they're good people. You have a nice program, someone says, I'd like to use that. Of course, you give per a copy. And if person says, oh, I added this feature, you could ask, I'd like that code, and you would get it.
When did chat programs start to become popular? And I'm not talking about IRC chat. I'm talking way before IRC chat. I'm talking like,
I don't
in the
know.
early
I
70s.
didn't use them.
What?
ITS had a chat feature between terminals of the same computer, but it was actually not a program. It was a feature of the kernel,
Really?
part of the terminal controller.
When did they
Now-
cross between one computer and another computer or another system?
I don't remember.
Uh-huh.
You see, on ITS, you could so easily go from one computer to another that you didn't really need a program to say chat to somebody on another ITS machine. You just remote login over there. Here's the thing I did that was fun. I arranged for remote login with local echoing, and I set it up so that you could even use it while editing in Emacs. So when you just typed some text to insert, it would echo locally on your terminal, but when you typed any other character, it would synchronize, it would then wait for that character to be executed by the remote Emacs, and then it would redisplay. But there were even a few characters that it could implement locally as long as you had not redefined them in the remote Emacs. If you redefine them, it would tell the system, don't do those characters locally, so that they would get the correct redefined results.
Yeah, I can remember when I was playing around with some of these computers over the ARPANET. As I typed, I could type way ahead of, and then the characters would come after I typed several seconds later.
Yeah,
it must
well,
have
that
used
was
some
what
type of
happened
an
when you had
internal
remote
buffer.
echo.
What?
The point of this, what you were getting was remote echo, which was the usual case. What I implemented was to optimize that by doing local echo when it could be done correctly.
Right.
And that made it a lot faster and easier to run Emacs on a remote machine, but you could get the fast responses if it were local.
So when did you implement that?
Oh, probably 77 or 78 or something like that. I don't remember exactly.
Yeah, that was long after I'd been on the ARPANET, because I got off the ARPANET around 73, 74.
Well, that was before Emacs and before this.
Yeah.
So
I was going
anyway,
on. I was connecting through NASA Ames computers, actually. I had a tip at NASA Ames. I also had a tip at Stanford I could get on.
You know, there were, they introduced a second generation of imps. There was the pluribus imp and the pluribus tip that was called a p-tip. So I kept wondering whether they should call the pluribus imp a pimp.
Was that using 64 KB data speeds at that
I have
point?
no idea how they worked.
Oh, okay.
I worked on the operating system kernel and other operating system programs, but I had nothing to do with the ARPANET itself.
You were writing all this in assembly language, though, right?
Yes,
Wow.
except for Emacs, which I wrote in Tico.
In what?
And I once went to a talk that was given at Wellesley College about Emacs. I sat down in the auditorium, but I didn't make the teacher aware I was there. The teacher ended it by presenting a little bit of Tico code and said, whoever wrote this had to be a fool and a genius. So then I walked up and introduced myself.
Tell us a little bit about this Tico code you were talking about.
Well, the Tico language was designed for editing commands. So you could type 5D and it would delete 5 characters.
Okay, I
Or
remember
3K and it would kill 3 lines. Or you could type an address and then J and it would go to that position in the buffer.
Was that the precursor to VI?
No.
Okay.
Tico was originally did not respond character by character. You would type an entire command string, which was a series of any number of commands, and then you would type alt mode, and the commands would run. And
could you actually see it edit on the screen as it was proceeding
at MIT
through it?
you would. On ITS you would, but on other systems no, because it was written for printing terminals. So you had to give commands to print out some lines when you wanted to see them. But at MIT, it would redisplay part of the buffer around point after each command string. The crucial point is that command strings could have loops and conditionals. You could put a command string in a register, and then you could use that register as a macro. And thus, Tico turned gradually into a programming language. When I wrote Emacs, I added a lot more programming features that you would find in other languages, like having a long name for a variable or a function. I also implemented facilities that spread into other languages after, such as something to do if an error happens. Well, Lisp had that, but also something to do for unwinding that would happen whenever there was a non-local exit for any reason. You would be able to supply in an unwinding macro to be executed to clean things up.
When was Tico first developed?
Well, I don't know. I believe it was in the early 60s, but I'm not sure.
Really, that early, huh? Wow.
So the original Emacs was written in Tico, which was written in assembler. But Bernie Greenberg, when he wrote Multics Emacs, decided to implement it in Lisp. And since he had a compiler for his Lisp implementation, he'd written that too, he was able to make Emacs run reasonably fast, even though it was all written in Lisp. And Emacs for the Lisp machine was also written in Lisp. When I wrote GNU Emacs, I didn't have a Lisp compiler. I had to write a simple Lisp interpreter, and I knew it would be slow.
Yeah.
So I had to implement some important things in C to make them fast enough.
We jokingly called it lots of incomprehensible, silly parentheses.
Yes, but Lisp is actually the most elegant syntax. That's one of its advantages compared with other languages.
Yeah, you don't have to type so much. What about APL? Have you worked with APL at all? A programming language?
I did in 1970. I wrote a text editor in APL.
Really?
Because I loved APL and I was fascinated by text editors, so I wrote one. But I couldn't get it to read or write files back then. There was no way to do that.
You mean the language itself didn't have the capability of
Right.
reading files,
It had
huh?
no facilities to read and write files. You could only set variables in your workspace.
Wow.
Too bad. But I did write a song about APL.
Uh-oh. Do you have it? Can we hear it?
Row, row, row of X always equals 1. Row is dimension, row, row, rank. APL is fun.
Cool. Yeah, do you remember this?
I can't see what it is.
Oops.
I don't have no idea.
Oh, you can't see the video on here, on our side? Oh,
No,
okay.
I don't know what you're showing me. It's a blue object.
It's my namesake. It's the Captain Crunch whistle.
Oh, I never saw one.
Oh, okay.
I read about that, but I didn't do any phone freaking, and I never saw one.
Yeah, Stanford. No, I think Stanford had. I think the AI lab had a blue box program on the AI lab, as I remember correctly. It was pretty much kept under wraps. They wouldn't. Not too many people knew about it.
Well, one thing I liked about the Stanford AI lab system was they put the hardware manuals in directory H, doc, and the system manuals in S, doc, and then the manuals for the user programs were in UP, doc. And people would ask about that directory, what's up, doc?
Okay. So tell us a little bit about how you started the Free Software Foundation. When did it start? Who got involved in it besides you, and where is it headed today?
Well, actually, the Free Software Foundation is not the most important thing. First, I started the free software movement.
Movement there.
See, people think that first you start an organization and then it starts a project, but this was the opposite. First, I launched the development of the GNU operating system, and that was part of the free software movement. The movement is to get freedom in our computing, and that means you need control over the programs you're running. If
So
you're
what year
running
was that?
a program that is non-free, then you can't change it, and nowadays it's probably designed to mistreat you. But that wasn't true in 1983.
That was in
1983, proprietary software was generally not malware, but it was still an injustice that the users couldn't change it and share it. So I said, I'm going to fix that by making an operating system that everyone is free to share and change, and that's the GNU system.
And when was this out?
GNU is not Unix.
What year was that?
That was in 1983 when I made this decision, and I announced it in September. Then in January '84, I quit my job at MIT so that MIT would not be able to claim copyright on this code. I knew that I needed to release it in a careful way, and I didn't want to MIT to be able to stop me.
What platforms did you...
developing GNU. I started the Free Software Foundation in October '85. Because at that point, there was already a GNU program that people liked, namely GNU Emacs, and that gave the project some credibility. In 1983, before I announced anything publicly, I looked for funds, and nobody was interested in giving any. Well, I thought in October '85, now that we have some real software that people like, maybe now we can get donations. So I started a charity, a charitable foundation, which is tax exempt, to make it easy to give donations. However, it turns out that the way we got our money was by selling magnetic tapes.
Oh, wow. What platforms was the GNU first implemented on?
Well, GNU itself was going to be a platform, but at the beginning, when I started writing pieces of it, I was replacing Unix piece by piece. So, of course, I had to write these pieces on Unix.
Ah, okay.
But the goal was to get rid of Unix. Once everything was replaced, Unix wouldn't be needed anymore. And that was the whole point, because Unix was proprietary. You can't have freedom running Unix. You can't have freedom running any proprietary program. But Unix, using Unix was okay as a way to develop its own replacement, as long as I did not sign a non-disclosure agreement. So I couldn't sign a license to get a copy of Unix.
Which Unix was this? Was this BSD Unix or ATT Unix?
Mostly it was BSD Unix,
Okay.
because that was better. Its interfaces also were more sensible, partly because they had been influenced somewhat by ITS.
What does ITS stand for?
Incompatible time-sharing system. You see, MIT was famous for having developed around 1960 or so something called CTSS, the Compatible Time-Sharing System, which was one of the two first time-sharing systems. I believe the other was also at MIT on a PDP-1. In any case, CTSS stood for Compatible Time-Sharing System, and what that meant was you could run a program that was written for the bare machine. It would run under time-sharing also. But when the AI Lab hackers wrote ITS, they decided it would be too much trouble to try to simulate the bare machine's I/O instructions. So the system they were writing would not have that kind of compatibility, and thus the name Incompatible Time-Sharing System was appropriate. Later on, the name stayed the same, but what it was incompatible with changed. At one point, when most PDP-10 users ran Digital's time-sharing system, well, ITS was incompatible with that. And then they started running 10X, and ITS was incompatible with that. It was always incompatible with something.
I remember 10X. There was a couple of computers that had access to 10X on through the ARPANET. I don't remember which one it was, but it was somewhere in the kind of early to mid 70s, I think.
One of the interesting things was the way that we kept our community working reasonably smoothly, and whereas in most places where they had a computer, they appointed a few dictators and they controlled what everyone else could do. And if you wanted to do something that you weren't allowed to do, you had to beg for some privileges. And if they caught you doing anything they thought was at all suspect, they would turn off your account. Basically, it ran like a fascist police state. We at the AI Lab were disgusted by that because, of course, we saw it from time to time at other places. And this is what we avoided by not having security in ITS. But we did occasionally have disputes or behaviors that were problems, and instead of trying to stop them by having the dictators who were all powerful and could control everyone, we dealt with those problems by talking with people. Once the ARPANET enabled lots of people to log in, and some of them were habituated in dealing with other computers to think that the authorized users and the administrators were going to regard them as vermin. And so they started trying to act like vermin because they knew they were expected to. And they would come to the AI Lab and do this, and we would talk to them and say, we don't think of you as vermin. We think of you as a tourist You want to use our computer? Please be nice to us.
Back in the days, there was often that the system administrators and the hackers got friends because they were the only ones using the computers, right?
We system administrators were hackers. Remember what hacker means. It means enjoying playful cleverness. We were very offended when people started assuming that hacker was equivalent to security breaker. Remember, at the AI lab, we had a lot of hackers, and we never had any security breaking because we chose to leave out the security instead. But we were hackers. We were doing various playful, clever things.
Of course, everything was open.
What?
Everything was open. You know, there was no security.
Everything was free.
Well, free too.
People were free. They were free to copy the code. They were free to change it too, as long as they made improvements. We didn't mind.
What happened when people didn't make improvements?
Then someone else would change it. Now, remember, I changed the operating system lots and lots of times. And a substantial fraction of those times I made a mistake, which means my change was no good. And you know what happened? Somebody fixed it, maybe me. Or maybe someone else happened to notice the bug and fixed it instead.
Do we have any questions here in the room?
I was just thinking about that. Anybody here have any questions for Richard Stallman? This is your chance. Speak up or forever hold your peace.
Yeah, we try to say that.
What about the questions on the GeekFest site? Any come in?
It's not really a question. I don't find a question mark, but I will read it to you. Is there a question in the room?
Yeah, go ahead.
Do you think free software is better off now or worse than?
I'll repeat the question. Do you feel that software, free software, better off now than it was 10 years ago?
Well, some things are better and some are worse. We now, for the first time a couple of years ago, it became possible to buy a computer that would come with a free operating system and free drivers and free boot software. In other words, all the things that you'd want to replace, they come as free software to begin with. And it's a totally free GNU/Linux distro. Well, this is something we dreamed of for years. But at the same time, some things are getting worse. All modern Intel and AMD processors are designed with disgusting back doors that you can't turn off.
Yeah, I've heard about that, and that really sucks.
So at some point, we're going to have to start trying to fabricate CPUs.
Maybe make our own chips. There you go.
That's what we're going to have to do eventually.
Because all those big, powerful semiconductor companies, you're right. They must put all kinds of nasty little things in there.
Well, we know that it's a universal backdoor usable over the internet. If you get a recent Intel CPU, it can be reached. They can turn it on, turn it off, change anything on disk, whatever they like.
Yeah, the NSA already can do that.
Well, not just the NSA, but anyone who knows the appropriate code. They can do that through the management engine in modern Intel chips, Intel CPU chips.
Also on the Macintosh, they actually had the Dropbox just last week was caught that they implemented a control feature and administer account on all new Macintosh systems, and they fooled the people by telling them that they need to give their password because Dropbox would not work correctly, and in fact they hacked the system with their password.
Could you email me a URL of an article about this?
I can do.
Because in GNU.org/proprietary, we have lists of dozens of cases of proprietary malware. The most widely used proprietary software products are malware. Now, by malware, I mean that their operation is designed to mistreat the user. So there are two orthogonal issues here. Whether a program is free or proprietary, that's not a question of what's in the code. That's a question of how it is distributed, on what terms people are allowed to use it. Whereas malware is about what's in the code. The interesting thing is that malware and proprietary software go together. Nowadays, a proprietary program is very likely to be malware, and the reason is a proprietary program gives the developer power over the users, and power corrupts. By now, the developers have been corrupted by this power, and they develop a program with the specific aim of mistreating the users through it.
Yeah, and hiding their code into little hardware registers that you don't even know about.
Yeah.
They don't even need to do that. They just write it in the code normally, because they're never going to show the source code to the users.
Well, yeah, that
let
too.
alone let the users change it. So we have to realize that that's unacceptable practice. In other words, the free software movement has become more important with time. The injustice of proprietary software in 1983 screwed people like me, people who loved computing or used computers a lot. But how many people was that? In 1983, it was a tiny fraction of Americans who used computers very much. Nowadays, almost everybody does and uses them for very important things. We have to get rid of non-free software. For more information, look at GNU.org.
Well, that's going to be hard to do as long as people are making money doing it. That's always going to be the problem.
Well, we have to organize to push proprietary software out of our lives.
Yeah. Yeah, we have a question.
Yeah, there's a question here.
People are publishing software like on GitHub without putting licenses. Are licenses important to put on software?
Did you hear that?
Yes.
Repeat it, please.
A program, okay, well, he can repeat it.
We have to repeat it here for the stream.
Okay.
Repeat. You repeat.
Okay, people are putting software out on GitHub without licenses, without licensing or putting out, any ownership to it. What do you think about that?
That is a terrible mistake. It's a harmful practice. Today's copyright law makes every program copyrighted automatically, just like anything else that's written. And without a free software license to give users the four freedoms, the program is proprietary. Everything that's written is restricted by copyright unless you use a free software license to give users the necessary freedoms.
But who owns the copyright?
Well, in fact, the copyright holder is whoever wrote it, unless that person was an employee of someone else or had signed a contract. It may not be obvious by looking at GitHub who the copyright holder is, but the copyright holder is the one responsible for putting on the statement of permissions, which we call a free software license. Now, this GitHub has done great harm to the community by encouraging this practice. It also encourages people to indicate the licenses in a way that is not very clear. Every source file, except for tiny ones like 5 lines, should have a license notice that says the license of this code is such and such. That should be at the top of the file along with a copyright notice. This is the way you make clear to the user community what they're allowed to do with this code. Keeping people in the dark about this, which is what happens if there's no clear licensing, or risking that the code will be separated from the license, which means confusion about what is permitted, those are bad practices. And users, we need to educate users so that they will avoid these bad practices and show users, that is, the developers who are users of these repositories should show the users of their code clearly what the rules are for using that code. Take a look at gnu.org/software/repo-criteria.html for our criteria for an ethical repository.
Why don't you do this? Why don't you type it into the Jitsi Bridge text thing?
No one can see this.
Oh,
I don't know how to do that, but let's
Never
see.
mind.
It's not easy to read, I think, here on the screen.
Yeah, you're right.
Okay.
But you also want that schools use only free software, right?
They should. Look at gnu.org/education.
Okay.
I think that's easy to remember.
I thought you maybe talk about that.
Well, I'd be happy to, but I understand that we don't have all that much time, so I'm trying to economize when possible.
Okay, I understand. Okay, not too many topics. All right. Yeah. Are there any more questions in the room?
Yeah, we have one way in
We
the
have
back.
one more question.
All hardware is evil. Which hardware are you using?
I'm using a ThinkPad X60, and that's one of the models that can run with a free BIOS and a free system. It's totally free software.
Cool.
Great. The questionnaire uses the same, so he's excited now.
I'd like to emphasize the importance of copylefting your programs. If you write a free program and you release it under a pushover license, such as one of the BSD licenses or the Apache license, well, it's free. It is a contribution to our community, but its freedom is precarious because those licenses are weak. They don't defend the freedom of the users against unscrupulous users, often companies that will take all that code and put it into a proprietary program. This happened to Apache. You've probably seen statistics about what fraction of websites run Apache. Well, they're all using the code of Apache, but they don't all have freedom because a large fraction of them are running IBM's proprietary modified version of Apache. They get the code of Apache, but they don't get the same freedom that real Apache gives you. Well, the developers could have prevented that. All they had to do was copyleft it.
Brian Bielendorf, didn't he write the Apache originally?
I don't actually know.
Oh, okay.
I mean, I had very little to do with the World Wide Web until there was a free browser, because I wouldn't run a non-free one. And so back in those times, I'd heard of Apache. I knew it was free software, but that's all I knew.
Okay.
Any more questions?
I can't think of any.
No?
Do you have another song?
Yeah, you were asked whether or not you have another song.
Well, I have, here's one about email.
Yeah. Please.
I've been answering my email all the goddamn day. I've been answering my email 'cause my work gets done that way. Can't you feel the fingers aching, typing till early in the morn? Can't you see the letters blurring? It's just an ad for porn.
You should publish a CD.
Christmas album.
This is
I
a
don't have
great
anything else.
Yeah.
I'm kind of out of questions.
I think this is a great end, and I think we all want to applause to this man and what he has achieved. Do we want?
Yay!
Please go to fsf.org and join the Free Software Foundation. Also, look at GNU.org/help. It lists lots of different ways you can help our work. You'll find something that you can do.
Okay, well, we'll check it out, man.
Yeah. Thank you very much for taking your time and being here with us.
Happy hacking.
Happy
and
hacking.
Bye.
You.
Hack the world. Bye.
Bye.
Well, that worked out pretty good.
Yeah.
Anyway, we still have...
No, he's in the kitchen.
He's probably in the kitchen. There he is!
Hey!
I'm drunk.
Getting hammered, huh?
Kid.
Yeah.
Thank you for being with us. We've
Oh,
done,
it was,
we have
it
done
was
our
fun.
first day. It's we've
You're
done
toast.
it.
Yeah, wait till tomorrow, guys.
Hey, you have 3. Look at this. You
Oh
can,
my God!
You can always,
You got more Captain
you can
Crutch
always-
whistles than I got.
I see. You can.
You're more
comment.
important than me.
Man.
And the little wieners for long distance.
Oh, an
calls.
Oscar Mayer Wiener whistle. I remember those.
What could you do with that one?
You can blow
Long
2600 with that
distance
one
calls.
too.
Wow.
I remember the Oscar Mayer Wiener whistle.
All right, kid. Have a nice day.
Take care, you guys.
Yeah, I know you could do it for hours now.
Well, tune in tomorrow's GeekFest. All right.
Yeah.
Okay.
Tune
Good
in
job,
tomorrow.
you guys.
Bye.
All right.
Bye.
Cheers.
Thank you. Ja, es war jetzt wirklich der letzte Talk. Ich hoffe, es hat euch gefallen.
Trying to disconnect and it doesn't seem to work. All right, we're off, but we're still transmitting, but that's okay. Okay, we kill the stream.
We kill the stream?
We can kill the stream.
We can kill the stream. What live stream?
Next time, tomorrow, same time, same station. I'm gonna have my phone back, please.
Some callers, I didn't know what was.